The following question came in GATE 2020 Electrical. Question 5. The value of the following complex integral, with C representing the unit circle centered at origin in the counterclockwise sense is. The integral is given as integration of z square plus 1 upon z square minus 2z dz. The options are 8 pi I, minus 8 pi I, minus pi I, and pi I. Reference to NPTEL video. Advanced Engineering Mathematics, Unit 4, Residue Theorem by Professor P.N. Agarwal, IIT Roorkee. Useful data. If C is a simple closed, positively oriented contour, that is, it is traversed counterclockwise in a complex plane, and function f of z is analytic except for some points that are the poles of function f of z, generalized as z1, z2 all the way till zn inside the contour C, then as per Cauchy's residue theorem, the value of the integral f of z dz over the contour C is given as 2 pi I into the summation of all the residues of that function f of z. The residue of the function f of z calculated at a point zk inside the contour C is given by limit z tending to zk substituted in z minus zk into f of z. Solution. As per the question, the contour is unit circle centered at the origin, that is nothing but mod of z equal to 1. And the given function over which the integral to be evaluated is z square plus 1 upon z square minus 2z. Now, we need to evaluate integration of this function f of z over the contour C. As per Cauchy's residue theorem, integral f of z dz over contour C evaluates to 2 pi I into sum of all the residues of f of z. So, the residue can only exist for the points inside the contour C. So let us draw the contour in the complex plane. So for function z, the residues to be evaluated depend on the poles, that is, the point at which the function f of z is non-analytic. So the poles of f of z are z squared minus 2z simplified to z into z minus 2. So poles are z equal to 0 and z equal to 2. As this is a unit circle, this is 1, z equal to 2 lies here, and z equal to 0 lies here. So as z equal to 2 lies outside this contour, which is anti-clockwise, it is not of interest. Only point of interest is z equal to 0. Now, the residue at z equal to 0. It is given as limit z tending to 0, z minus zk, that is 0, into f of z, simplifying to z into z square plus 1, z into z minus 2. So z cancels out, and substituting the limit in the equation, the answer comes out to be minus 1 by 2. This is the value of the residue at 0, which is inside contour C. Now, the value of the integral f of z dz over contour C is 2 pi I into the value of the residues. As there is only one residue whose value is minus half, the final answer is minus pi I. Therefore, going back to the original question, thank you.